So, Robert, you mentioned the sea level changes, and not so many people would know that actually sea level changes are linked to changes in climate. And like that we have lower sea level when we have glacial conditions, there's more water from the ocean absorbed into ice. And again, it would be a surprise to some people that 20,000 years ago we had 200 meters of ice above County Cork. And I know you spent many years investigating the past climate, the glacial history of Ireland. So can you just elaborate on what was the role of glaciations in shaping Ireland as an island, and specifically the coast of Ireland?
It's a big, multiple, integrated sort of question. Ireland as an island, as you say, certainly has been part of a much wider glaciation of Ireland and Britain together as offshore islands in Europe, and part of the bigger European glaciations. And the island and these areas have been affected by ice over perhaps the last million years or so, most recently in geological time. And through those million years or so, Ireland certainly hasn't always been an island by any means. It's been part of the mainland areas, as with Britain, joined to Europe at times of low sea level. So the immediate sort of impact of glaciations for this part of the world has been times when sea level have been low, and lots of the islands as they are joined up as part of a much bigger land surface, allowing plants and animals to move backwards and forwards, as well as different sort of changes of processes. And our coasts migrating down as sea level has fallen to much lower levels. And of course, those levels today are underneath the present-day sea surface. They're submerged and we can't see them. But our continental shelves around Ireland have been glaciated and affected by that process of sea level rise and fall driven by glaciation.
And how did you manage to study those landforms that you can find on sea shelf before the invention of multibeam?
With the help of people like you.
But before multibeam, you couldn't study it, no?
No, they would have been much more difficult to certainly not observe. In order to observe the seabed and some of the morphological features of coastal change, which are now submerged, then remote operational vehicles, ROVs, have allowed obviously cameras to take us down, literally to observe the seabed and down to the bottom of the ocean. So we're talking about hundreds to thousands of meters of observational possibility going to the bottom of the oceans to see these places. In addition, of course, that's a new technology, but before that we couldn't see it. You'd have to go down in a submarine and you wouldn't see much in a submarine. So before that it would be simply echo sounding, as
single beam,
as sonar, for example, became available in the Second World War post that period, by simple depth, line and sinker soundings to get an idea of the shapes of the bottom of the seabed and so on. But actual observation of the shapes and forms is a very recent phenomenon for the last 20 to 30 years. So apart from the sea level as driven by glaciation, then glaciation itself, of course, has created our immediate physical shape to the coast in the present day, apart from the ones that are submerged now, and we can't see those except by remotely sensed techniques. But our modern day shape to the intertidal zone, that we can walk down at low tide and walk it up through to high tide, that zone of the present day coast, that there are lots of indicators of past glaciation there. We can find raised shorelines, for example, that show that as the ice that built up, as you described, over these land surfaces, such as Ireland and Britain and other parts of Europe, the land surfaces went down under the weight of the ice, and then as the ice melted away, those surfaces have come back up. They've bounced back up. So it's a geophysical process. Rebound. So that's called isostatic process, isostatic development. And as the ice has disappeared, the land surfaces have readjusted, and the raised shorelines that we find around our coastlines, for example in the north of Ireland, are that part of Ireland going up as the ice has disappeared. And in balance to that, because isostasy means balancing blocks of the Earth's crust. This part of the world, the south, where this office is here, is part of an area which is part of a subsiding to semi-subsiding part of the Earth's crust, balanced or balancing the rise of the Earth's crust to the north of Ireland. It's a little more complex than that. This is almost stable now as part of that isostatic process here. But that, for example, forms a physical coastline, our raised shorelines. Some of those
Can you
raised
give some
shorelines,
examples of the raised shorelines?
as around Malin Head, for example, most of the north of Ireland has raised shorelines that date from around 18,000 to 12,000 years ago. And progressively, as we come further south, those raised shorelines become submerged shorelines. They were cut by processes of wave erosion and storm erosion initially, and by ice action. And some of those bits of the coastline that are still visible show that ice imprint on them. They show the action of Arctic, as we'd see in Norway and Spitsbergen, for example, or in Iceland. We see Arctic coasts, or in Canada, Arctic type coasts dominated by very intense cold presence of ice on them, and cold atmospheric conditions, creating freeze-thaw, rock-shattering, ice pressure structures and features and erosional features. And they create a very special sort of narrow erosion platform, distinctly different from a tidal-driven erosional platform. So we find those all the way around many of our rock coastlines in Ireland, these narrow, glacially influenced rock platforms. And then they become modified by subsequent post-glacial processes. So there's little fragments of all sorts of elements of past climate of which ice was part.
And so you kind of covered it already. So just to summarize, like, what type of glacial features can we still see on the Irish coast? So would this be shore platforms and raised
shore
shorelines,
platforms, raised shorelines. Perhaps some of the cliffs in themselves are semi-fossilized, glacially driven sorts of coasts, in which the role of gravity hasn't managed to overcome the material left behind by the glaciers. We have other sorts of depositional coasts, perhaps very important for the east coast of Ireland, where the ice, as it retreated, left behind it all of the ground down rock debris, and that material forms the soft cliffed coastlines of the east and some of our big embayments along the south and the western coast of Ireland. So glaciation, again, as an imprint, is not so much in terms of the uniqueness of the coast, it's the material left behind by the ice that creates the character of that coast as the waves interact with it and create erosional type coasts. So soft and hard rock coasts are partly glacial in origin.
You mean glacial till cliffs?
Yes, the term is a boulder clays. Perhaps people commonly still understand material dumped by ice as boulder clays, but a more recent term has been till. So yes, that sort of sedimentary material.
What about periglacial pavements?
Periglacial is part of that fossilized freeze-thaw action that
Limestone cemented with
referring
itself.
to. Yes, yes.
And do you find them only on the south coast, or
sort of periglacial pavement you would find along the south coast in Ballycotton Bay, for example. Nice pavements created by those freeze-thaw frost actions that you'd find operating in Iceland or Canada, for example, today, in Ballyferreters Cove in Kerry. But most of our glaciated coasts would have elements of these fossilized freeze-thaw, or fragments of them anyway, within the present-day intertidal zones. They're perhaps less obvious and less surviving along the east coast, because that was covered by glacial sediments directly, and a lot of that has been eroded back, and so they've been destroyed because they could move very quickly, because it's soft material. The cliffs have eroded back, and a lot of that freeze-thaw pavement material has gone. So they're preserved more on our rock-dominated coasts of the west.